Alright, this is the notes for section 6.1, and to begin with I'd like to take a look at a little bit of vocabulary surrounding the term quadratic. When we talk about a quadratic, what we're really saying is we're looking at polynomials that have a degree of 2. So it's expressions, equations, and functions where we're adding together either constants, first power, or second power monomials. So basically the highest power that we can have is 2. So here's an example of a quadratic expression. Here's one that is in a quadratic equation. Notice how the difference is we just have an equal sign. It doesn't have to equal 0. Just being very general here. We can write it as a function in either form. Okay. When we write a quadratic in standard form, we have them going in decreasing order. So the powers on x, if it's just one variable, would be going down in decreasing order like we have here. And then finally, we have the general expression in terms of 2 variables. Well, most of the time in this chapter we're going to be working with 1 variable, but quadratics can actually have 2 variables in terms of both x and y, as long as the sum of the powers on any given term is not higher than 2. So this would be a standard form for a 2 variable quadratic. So to begin with, what I'd like to do is take a look at using quadratics with rectangles. So we have this example. It says a portrait is 20 centimeters by 90 centimeters. A frame around the portrait is f centimeters wide. Write the total area of the portrait and the frame in standard form. So the first thing we'd want to do anytime we have something like that where a picture can be drawn, we want to do that. So you might want to pause the video and see if you can draw a picture. I'm going to do the same at this time. Alright, so we have something that looks like this. We have, here's a picture in here. It's 20 by 90, and then I have this frame that's f centimeters wide all the way around the whole thing. So I put f on all 4 sides of that. So we have a rectangle that we're working with. And what we want to do here is we're looking to find the total area of the portrait and the frame in standard form. So that means what we're going to end up with is a quadratic expression. So let's see if we can do that. Well, if I'm going to find the area, I know that the area is equal to the length times the width. Well, if I look at my portrait here, I know that the portrait is 90, but the frame is f on each side, f here and f here. So I can say that the area of the portrait is, or the length of the portrait, excuse me, is 90 plus 2f. Now I can do something similar to that when I'm looking at the width. If this is 20 and I have f on each side, it would be 20 plus f. I'm sorry, plus 2f, because there's an f on each side. And now all I want to do is I want to multiply those two. So we've got to think back to what we did when we were working with the FOIL method back in Algebra 1 course. So I'm going to use the FOIL method to multiply this out. Alright, so to do that I'm going to take first 90 times 20, which is 1800, outer 90 times 2f, which is 180f, inner, which would be plus 2f times 20, which is 40f, and then finally last, 2f times 2f, which would be 4f squared. Now the last thing that I need to do here is I need to put this in standard form. So I'm going to write a equals, and I'm going to put my f squared term first. So it'd be 4f squared. Then I'm going to put these two together because they're like terms, which would give me 220f. And then finally I have plus 1800. And I now have it in standard form. You'll notice that my variable is going in descending order here. So this would be the answer we would be looking for. Alright, so we looked at quadratic expressions as they work with rectangles. Let's look at squares now as well. The expression x plus y, when we use that expression, that's an example of a binomial. There's 2 terms there. And a binomial is any expression that has 2 terms. And the square of a binomial can be thought of as the area of a square. So if I take a binomial and multiply it by itself, it's considered the area of a square. So what we want to do is we want to see if we can do this problem here, which says write the area of a square with a side length of 2a plus b in standard form. Alright, so what I've done first here is I've taken and I've drawn a picture of that, and really if it's 2a plus b, I could say like this. I'm just dividing my square into parts. If this is 2a and this is b, 2a and b, what I can do is I can find the area of each of those parts. So I can go 2a times 2a, which is 4a squared. I have 2a times b, which would be 2ab. I have 2a times b again, which is 2ab. And finally, b times b, which is b squared. So when I write that out, it's really the same as this right here that I have written 2a plus b quantity squared, which is the same as 2a plus b times 2a plus b. And I want to show you that if I multiply this using the FOIL method, I'm going to get the same thing here. Because over here, if I put these together, it's 4a squared. These two right here are common terms, so I can say plus 4ab plus b squared. So if that's the case, let's see if that's what I get here. 2a times 2a would be 4a squared plus 2ab plus 2ab right here. And then finally, plus b squared. And once again, if I put those together, these are like terms and end up getting that right there. So it is exactly the same thing. Therefore, the answer to this is the area of my square. All right, this problem right here leads to a more general theorem that is going to be really important as we move through this chapter, and that is the binomial square theorem. Binomial square theorem is going to be something that you're going to need to know really well, both forwards and backwards, as we move through this unit. So it just says for any real numbers x and y, if I take the sum of those two numbers and square them, it will always be equal to the square of the first, the square of the last, and then in the middle we take the two terms, the two numbers, multiply them together and double it, or multiply it by 2. Now, if the only difference is instead of a plus sign I have a minus sign, the only difference in terms of the binomial square theorem is that I have a minus sign here instead of the plus sign here. All right, let's take a look at this last example here. It says a large circular pipe coming up from the ground is surrounded by a circular region of drainage stones. The distance from the edge of the pipe to the outer edge of the drainage stones is w feet. So you can see that on the drawing right here. And the radius of the drainage stones, including the large pipe, is 7 feet. So this total distance here is 7 feet. Okay. Now it says write a quadratic expression in standard form. Make sure that it's in standard form for the area of the opening of the circular pipe, not including the drainage stones. So what I'm looking for is I'm looking for this area in here, not this stuff. Okay, so let's see if we can do that. If I think about the area, we're talking about a circle. So if I think about the area of any circle, I know it's going to be equal to pi times its radius squared. So I'm going to use that to help me. So I know the radius of the whole thing is equal to 7, but we also have this w in there as well. So the radius of this pipe then, this pipe here, would have to be 7 minus w. So the radius that we're looking at here is 7 minus w. So I'm going to use this in this equation to help me find that area. So I'm going to say the area is equal to pi times, instead of r, I'm going to put in 7 minus w. and I'm going to square it. Now, what I'm going to do is I'm going to use my binomial square theorem here, and I'm going to say, okay, so area then is equal to, and I've got to do that first before I distribute the pi. So I'm going to say 7 squared, which is 49. Then I do the last term squared, which is w squared. And in the middle, if you remember from our binomial square theorem, so when I go up here, I look at the binomial square theorem, I'm looking at this minus 2xy. So in this case, it'd be minus 2 times 7 times w. So it'd be minus 14w. This would still be plus w squared here. So I'm getting close, and now what I want to do is I want to distribute the pi, and also I'm going to put it in standard form. So I'm going to take pi times w squared. So area is equal to pi w squared. And then I'm going to take pi times the negative 14w, which would be negative 14 pi w. And then finally, plus 42 pi. And now I have it in standard form for a quadratic. Alright, so to complete your notes, what I'd like you to do is see if you can do part B here. And then when you get to class, we will try and talk about that. I'll probably give you a little bit of time with your groups to kind of talk through that, and then we'll talk about it as a class.